Hey guys, it's Off1 here, and today we're going to be solving climbing stairs. In this problem, we're told that we're climbing the staircase and it takes n steps to reach the top. So for example, if n equals 2, that means we have 2 steps like this. And in this problem, you can either climb 1 or 2 steps, and they're asking us to return how many distinct ways could you climb to the top. So for n equals 2, we could take 1 step here, and then 1 step here. Or we could just climb both steps in one go. So that means there are 2 distinct ways to climb the steps. So now let's go over the scenario where n equals 3. How many distinct ways can you climb 3 steps? Well, let's see. We could do 1, 1, 1, and that's one way. We could jump 2, and then go to 1. That's 2 distinct ways. Or we could jump 1 step, and then take 2 jumps to reach the end. And that would be 3 distinct ways, which matches up with our output here. Before we go forwards, let's take a step back. How many different ways can you climb 1 step? Well, that's pretty obvious. We can only do 1 hop. So the max amount of ways you can climb the step is 1. And what about for n equals 0? Well, if there are no steps, we can just say there's only one way to climb the steps, and that is by not climbing them. So let's go back to our n equals 2 example. We can see here that we already calculated n equals 1 for this step, and there's only one distinct way because we can only take 1 hop there. And to get to the second step, there's only one more distinct way, and that is by taking a big jump. So we can say that to climb 2 steps, it takes 2 different combinations. Now let's go to n equals 3. Same thing here. To get to the first step, there's only one possible combination. And then to get to the second step, we can see that there's 2 possible combinations, the same as n equals 2. So what we can notice here is that we're doing a lot of repeated work. And then to get to the third step, we can see that there's one additional way to get to the third step, and that is by this path. And so if we were to solve for n equals 4, we can see that we don't need to solve for 1, 2, and 3 all the time. We can just store n equals 3, and then calculate how many new ways you can get to 4. So let's try that. I'm going to organize the examples a little better so you can see the pattern more clearly. So here I've redrawn the examples, and I've also drawn the example for n equals 4. So what we can see here at the beginning is that n equals 0, there's only one way to get to that. For n equals 1, only one way to get to that. N equals 2, there's 2 ways to get to that. And then for n equals 3, there's 3 ways. So let's solve n equals 4 to see if there's some kind of pattern here that we can use in our code. So we know that for the third step, we're always going to have 3 combinations. To get to the fourth step, we can either extend just 1 hop there, which would give us d equals 4, or we can jump from 2 to 4 all the way there if you imagine that, and that would give us another path to get to 4. So n equals 4 would equal 5 distinct ways. So what do we notice here? We can see that for n equals 4, we're using d equals 3 and d equals 2 and adding them up. So we get d equals 5. And we can see that this pattern continues backwards. So n equals 3, the d would equal 3, which would mean if we add 1 plus 2, we get 3, and that checks out. And then for 2, we have our base case of 0, and our n equals 1, and 1 plus 1 is equal to 2. So how can we write that in code? Well, let's start by storing all these values in an array. So I'm just going to call it array, and array of 0 would be equal to 1, array of 1 would be equal to 1, array of 2 will be equal to 2, array of 3 would be equal to 3, and array of 4 would be equal to 5. So let's say we're trying to calculate the array of 4. To do that, we could do array of 4 is equal to the array of 3 plus array of 2. But how do we calculate the values that are in n equals 3 and n equals 2? Well, to do that, we can generalize this a little better and run it through a for loop. So here we have our pseudocode, and we're going to run a for loop from 2 to n plus 1. And the reason we start at 2 is because our base cases are going to be 0 and 1. And the reason we do n plus 1 is because we also have to make room for the 0 here. Once we do that, at the end we can just return the array at index n, and that should give us our result. And the solution here with the array would take us O of n time, because we have to iterate from 2 to n plus 1, and the space would be O of n, because we need to store all of these values in an array. But there's actually an improvement we can make here. Instead of O of n space, we can actually solve this in constant space. And the way to do that is, since we only ever use the previous two, we can just store these in variables and update them as we go through the for loop. I'll show you how to do that in the code, so let's get into it. To start, we just want to initialize our base cases. So we have our base case of n equals 0, and we can just call this previous and set that equal to 1. And then we have our base case of n equals 1, and we can call this current and set that equal to 1 as well. So previous is going to represent I minus 2, and current is going to represent I minus 1 from our pseudocode. And then now we just want to run a for loop. So from 2 to n plus 1, what we want to do is store our current variable in a temporary variable because we're going to update it here. So current is going to be equal to I minus 1 plus I minus 2, if you remember that. And then now we want to update our previous to our current. But the problem with this is that we just updated it here, and that's the reason we use this temporary variable. And then now we can just return current, and that should work. Forgot to put in here, but now it should work. As you can see, this code is pretty efficient, and now I will step through the code manually. To start, we want to initialize our previous and current variables. So previous is 1 and current is 1 for n equals 0 and n equals 1. And I've already done that here. I've named them P and C just so they can be smaller. And now we're going to iterate from 2 through n plus 1, and we're actually just going to be going all the way to n because range is not inclusive. So basically the way this reads is iterate from 2 to n. And so now we're going to update our temp variable to be equal to our current, which is 1. And now we have our current is updated to our current plus our previous. So 1 plus 1, that would be 2. And then our previous is updated to whatever our temp value is, which is supposed to be our previous current. So this is going to be updated to 1, which is already 1. And now we go to the next iteration. So temp is going to be equal to current. So temp is now going to be 2. And then current is going to be current plus previous, which would be 3. Previous will be updated to our temp, which is currently 2. And now we go to our fourth iteration, where n equals 4. And now we have temp equals current, so temp is equal to 3. And now we update our current to be equal to current plus previous, so 3 plus 2, which is 5. And now we update our previous to our temp variable, which is 3. And now we go to our last iteration, where n equals 5. So we update temp to be equal to our current, which is 5. And then we update our current to be equal to current plus previous. So it would be 3 plus 5, which is equal to 8. And now we just update our previous to be our temp, which is 5. And then at the end of all this, we just return our current, and our current is 8. And we know that if we have 5 steps, there are only 8 combinations, so that is correct. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.